So we're going to do the alternating series test today. And alternating series just means that the terms alternate their signs, positive, negative, positive, negative, positive, negative. So if you have a -1 to the n, that means that your odd terms are negative. Because if you plug in any odd number, like -1 to the first, -1 to the third, like that's going to stay negative. If you have a -1 to the n plus 1, then your even terms are going to be negative. But the point is, if you see a -1 to the nth or a -1 to the n plus 1, the terms are going to alternate, and that's an alternating series. So when you're going through this and going, what on earth test am I going to use? This one's very easy to identify. Do you get what I'm saying? Like it jumps out at you, oh, this is an alternating series. So that is one like good thing about it. So to do an alternating series test, number one, the series has to be alternating. You would think I wouldn't need to say that, but I just want to be clear. You can't do an alternating series test unless the series is alternating. Okay. So second thing, your limit as n goes to infinity of the series has to go to 0. It's like you're doing an nth term test and it comes out to that no conclusion. Basically, you're just showing that it doesn't diverge is all you're doing there. You're just showing it doesn't diverge. And then the third part of it is absolute value. And the reason we have absolute values in this is because the terms alternate, okay? Absolute value of your n plus 1th term has to be smaller than absolute value of your nth term for all n. And what that means is the terms keep getting smaller and smaller and smaller and smaller. If you're like n plus 1th term is smaller than your nth term, like they keep getting littler is what you're showing. Now, as a side note, it could still converge if number 3 is not true. You would just need to use a different test to prove it. If number 3 is not true, it means your alternating series test failed, but it could still converge. You would just need to use a different test, which you would use one of the ones we haven't gotten to yet. Because if it was one of these, like if it was geometric or p-series or something, you would have done that already. Okay, so let's just try a few of these. These go really easy. I'm going to do these and then I'll give you a couple to try. Do you see how it's alternating? Yeah. Like, so you don't have to write that. Like it is alternating. We have that -1 to the n plus 1. Okay, so we're going to do limit. Ooh. Limit as n goes to infinity of 1 over n. When you do that limit, you don't include the alternating part. That's not changing what's happening. That's just making the terms go positive, negative, positive, negative. So as n gets bigger and bigger, the denominator gets huge. And so what is this limit going to go to? 0. Perfect. All right. And then we're going to say 1 over n plus 1. You're just plugging n plus 1 into this. And you're probably like, why didn't she put an absolute value? You don't need to put an absolute value. Basically, just leave off the alternating part. Like, just don't write this part. Does that make sense? Like, then you've done the absolute value. Is that less than or equal to 1 over n? So you plug in n plus 1 for n, and then you debate, is this true? Like, is this a true statement? Would this be smaller than this? Yes, because this denominator would be larger. The one that has the larger denominator is the smaller fraction. For example, a 7th is smaller than a 6th. Do you get what I'm saying there? Okay. Now where does this start? N is 1. For n bigger than 1. So since our limit went to 0 and this is true, we say converges by alternating series test, and that is abbreviated AST, and that is a standard abbreviation. Kind of like how mean value theorem is MVT. Alternating series test is AST, and that's just accepted for that. Let's try it again. Do you see how the series is alternating? You have that -1. Okay, so we've established that it's alternating. Now we're going to do our limit. limit as n goes to infinity, 1 over 3 to the n. Again, just leave off the alternating part. So as n goes to infinity, that denominator is going to get bigger and bigger and bigger. So the limit goes to 0. So it's basically like you did an nth term test that came out to a no conclusion. And so that's why we have this third step to it. Again, we're going to leave off the alternating part, that negative part, just leave that off. You're going to plug in n plus 1 for n. And is that smaller than 1 over 3 to the n? Yes, the thing with the bigger denominator is the smaller fraction. So this is going to be a larger denominator than this. So that is going to be true for n bigger than 1. And so it converges by the alternating series test. So number 3, do you see how it's alternating? You have that negative 1 in there. We're going to do our limit. Limit as n goes to infinity of n over ln of n plus 1. I'll have to have a conversation about these to remember this. An exponential grows faster than a polynomial, which grows faster than a logarithmic. So n to the first, I know that seems kind of boring, n to the 1, but that's a polynomial. Then it's linear, but it's a type of polynomial. That is going to grow faster than a logarithmic. Again, your ln graph is that one that kind of like, it is going to increase, but it's kind of lazy. So since your numerator is increasing faster than your denominator, where does this limit go to? It goes to infinity. So what does that mean? Diverges by what test? It's not actually the alternating series test, because at that point, it didn't really matter that the series was alternating. It diverges by which one of these? Your nth term test. Cool. I'm going to just give you guys 2 to try here. Just maybe draw like a squiggly line. I'm just going to give you to try. I'll pause the video and we'll make sure we're all good. You can practice drawing a sigma. So for this first one, when you did the limit as n goes to infinity, you would have n over 2 to the n plus 1. N is a polynomial. I get that it's just to the first, but still a polynomial. This is what? The denominator part. If this is a polynomial, what is this? Exponential. So that means the denominator is going to grow way bigger, and so the limit will go to 0. The denominator is getting exponentially large. Okay, so it's like an nth term test that had no conclusion. Then we're going to do the next part. You plug in n plus 1 for n. So you'd have n plus 1 over, ooh, this is a little tricky. It would be 2 to the what? If you plug in n plus 1, yeah, it'd be n plus 1 plus 1. So it'd be n plus 2. Is that smaller than like what we had in the first place? And sometimes I'll like plug in 1 to see what I get, but this will be true. Because again, this being exponential, adding that in there, you're making the exponent larger. Here, let's plug in 1 just for giggles and see what happens. If you plug in 1 plus 1 would be 2. What would you have over here? Yeah, 2 cubed would be 8. If you plug in 1 over here, you would have 1. Oh, actually, they would come out the same for that, but equal to is okay. And then any number bigger that you put in, this denominator is just going to start growing like way faster. Okay, so that is going to be true, but sometimes I'll do that. I'll just like plug in 1 to see what happens. And so converges by alternating series test. All right, this one. Limit as n goes to infinity of n plus 1 over n. What did we think about for that one? Why does that come out to 1? Because that's correct. Coefficients are 1 over 1, which is 1. So what does that mean that we got 1? And you would say diverges by nth term tests. It's like you never got to do an alternating series test because you got that it diverged before you even got there. Again, alternating series test is basically an nth term test, but then like one extra step. But if you get that it doesn't work, like if the door closes on you, it's just by nth term test. Cool. Are we all right? All right. The other part of this lesson is what's called an error bound. Remember how for geometric, we can actually get the answer to the series. For the rest of these, we're just doing, does it converge or does it diverge? It's kind of the best we can do. Well, here you can actually approximate the answer. You can't get it exactly, but it's an approximation, okay? So this is used to approximate the sum of the series. So you're not getting it exactly, but you're using it to approximate. Now, what I'm about to write is going to look, it's a bunch of symbols and it looks kind of complicated, but it's actually not. So just sort of bear with me. And everything is going to have an absolute value around it because all the terms alternate positive, negative, positive, negative. So we have to absolute value them all for it to make sense, treat them all like they're positive. Absolute value with a capital R. That is your remainder. That's why we use R. Or you can call it the error, which is usually what I call it. It's R for remainder, but I call that the error. That's like how much you're wrong by. Because again, we're not finding it exactly. It's like we're going to get close, but that's how much you're off by. Is everyone following me so far? Remainder, that's like you got close, but that's how much you're off by. So that is going to be the actual sum. S is the actual sum minus the partial sum that you did. So this is like the true answer, that capital S. And this is your approximation. So capital S is like the true answer if you were able to add up to infinity. S sub n is like we added up n terms. So we added up 3 terms, or we added up 4 terms, or we added up 5 terms, but it stopped somewhere. So what this error bound tells us is this error, like if you subtract these, it's how much you're off by. That is smaller than or equal to the n plus 1th term. And that's the huge takeaway, because I get that that looks like a super complicated thing that we just wrote out. But if you just want to put like a too long didn't read version, the error is smaller than the n plus 1th term. That's the big takeaway. Your error, how much you're off by, is going to be smaller than the n plus 1th term. That's the big takeaway. And we will use a calculator for these two because the decimals are going to get to be kind of a lot. Now also, and I hope this should make sense, the more terms you add up, the better your approximation is going to be. If you only add up 3 terms, it'll be okay. But if you add up like 20 terms, it'll be even closer. Do you get what I'm saying? It's like the more you add up, the better your approximation is going to be. So we're going to approximate this sum using the first 6 terms. So we're going to generate the first 6 terms of the series. We talked about this before, but do you remember what the n is? Like n with an exclamation point? Not adding, but multiplying. And does anyone remember what it's called? Factorial. Good. It means you're multiplying all that together, and we're going to get a calculator, so it's going to be okay. All right, so let's try plugging in 1. If you plug in 1, will your first term be positive or negative? Positive. Good. 1 plus 1 is 2. Negative 1 squared is going to be positive. And 1 factorial is just going to be 1, and 1 over 1 is 1. All right, so your first term is 1. Start over at the edge of the paper because this is going to be kind of a lot. All right, plus, now we're going to plug in 2. Will your second term be positive or negative? I still always put plus though, and then I'll just put a negative with the term. Okay, so if we plug in 2, 2 factorial is 2 times 1, which is 2. So this will be negative a half. All right, now we're going to plug in 3. That term will be positive. Once you get it started, you kind of don't have to think about that anymore. It's just going to alternate. If you plug in 3, 3 factorial means 3 times 2 times 1. So 6. So 1 6. And then your next term is going to be negative. We're going to go to the calculator soon, but let me see if we can do one more. I usually encourage everybody to have the first 5 memorized, like up through 5 factorial. If you plug in 4, 4 times 3 times 2 times 1, it's 24. And then if you plug in 5, it's 120. And again, I usually just encourage everybody to memorize it up through 5. Beyond that, let's use the calculator. So can we do 6 factorial in the calculator? $720. You can either just type 6 times 5 times 4 times 3 times 2. There is a factorial in here. I'll go through where to find it, but you're not going to use it too much. If you type 6, go into your math menu, and it's under probability. So if you go over to probability, it's in there. It's the 4th one down. But you can always just type 6 times 5 times 4 times 3 times 2. And actually, I don't think we had to go any further, did we? First 6 terms. Okay, so what I'd like for you to do in your calculator is add up that list and then turn it back into a fraction. That is math 1. If you do math 1, like in your math menu, math enter, basically, it'll turn it back into a fraction for you. But go ahead and add those all up. I messed up my first try. I hit a wrong button. I got 91 over 144. I heard confirmation on that. Let me just wait till everybody else can get there. Yes, okay. So out of everything I wrote up here, which thing did we just find? We found S sub n. We summed up, and n in this case is 6. Okay. This is what we're trying to approximate is the actual true answer. So we're going to have absolute value S minus S sub 6, because n was 6. And we're saying that that error is going to be less than the next term. So if we added up the first 6 terms, it's going to be smaller than the 7th term. Okay, so let's go ahead and put that in our calculator. If you plug in 7, it's going to be 1 over 7 factorial. So let's do 7 factorial. You guys use the factorial a little bit in ProbStat? You use that? Did you use it in IB Math? Okay, interesting. I wonder if you're going to. Did you get 5,040? Okay, so your error is smaller than 5,040. That means your error, like your approximation's pretty good, right? Because your error is going to be smaller than that fraction. Now what we're going to do is split this into 2 separate problems, and we're going to use the calculator. I don't know if you remember this, but you did it back in Algebra 2. When you did these absolute values, you did one that looked the way it was and one where you flipped the symbol the other way. No? Okay, it's true. You did it. Okay, so you're going to have S minus, what was our S sub 6? It was this, right? 91 over 144. That's going to be smaller than 1 over 5,040. And then your other version, you flip the symbol around and you make it negative. We're trying to figure out what our actual true answer is in between. We're saying we're only off by a very small amount. I guess the other way you could think of this, like that's how I always write it out, but here's the other way you could think of this. Here, come with me on this thought journey, because actually I'm thinking this might make more sense than writing it this way. Here's what our approximation was. We're only off by this much. So if you take 91 over 144 and subtract this, and you take 91 over 144 and you add to this, do you get that like your answer will be, oh, that makes more sense. Let me erase this and we'll think of it that way. I just had that thought in my head. I was like, that'll actually make more sense if we do it that way. Take 2. Not that this was wrong in any way, but I'm just thinking that might make more sense. So this is what our approximation was. If you take that and you subtract your error, and you take that and you add your error, you know that your true answer's got to be somewhere in between because you're only off by that much. Now here we'll go to a decimal instead of a fraction because the fractions are like awful. I'm sorry, I know you erased. I just thought that would make more sense. If you subtract it and you add it, your true answer is going to be somewhere in between. And you can just watch me. I typed it in. I got, let me make it into a decimal. 0.631 is what I got for the subtracting one. And then if I go back and add it, I'm going to just bring it back and change the subtraction to addition. If I add it, I got 0.632. And there are obviously like more to the decimals. I guess I could have written out more numbers, but the point is, it's pretty accurate, isn't it? Like, if we know our true answer is somewhere in between these two, we narrowed it down pretty good, didn't we? So we can't find it exactly, but I think we did a pretty good job. Now, here's how this shows up on the AP exam. And this shows up often, and it's a really easy way to get 2 points because they usually make it worth 2 points. What they'll usually say is, show the error is less than, and then they'll give some arbitrary kind of number, like in this case, they'd probably make it like 1/5000th. This is usually what they'll say. They'll say, using n being 6, show the error is less than 1/5000th. Here's the big takeaway. If they tell you n is 6, your error is smaller than, if they tell you n is 6, the big takeaway is your error is smaller than which term? 7th. So here's what you would write. Error is smaller than, and then you would do the 7th term, which we already did it, so I'm not going to do it again. It would be 1/5040. So again, if they tell you n, let me make up another one. If they tell you n is 3, that means your error is smaller than the 4th term, okay? So you would just write error smaller than, and we found the 7th one. And isn't that smaller than 1/5000th? And you get 2 points for that. They usually make it a point for finding this, and then a point for saying it's less than whatever they told you to say it was less than. But it confuses people because they'll make up some totally random number that isn't what this comes out to. Do you get what I'm saying? But it'll be less than. Anyway, that's how it usually shows up in the AP exam. Let's just try one more. This one's a little bit backwards. How many terms will it take? So instead of being given n, that's what they're asking for. How many terms will it take to make sure that our error for this is less than 0.001? So what we're going to do is plug in n plus 1. And again, you can ignore the alternating parts. I'm not going to use that. We're going to plug in n plus 1. And our error will be less than 0.001. Why did I plug in n plus 1 and instead of just n? Like, why didn't I just copy this over 1/n to the 4th? Why did I put n plus 1? N, like, oh my gosh, it's the hugest takeaway. It's the n plus 1th term, guys. Are we coming? Like, oh my gosh. Okay, that's what you got to get out of it. And then you're just going to do the algebra to solve this. So what would you do to start solving that? You got to fight your way through the algebra of that. I would multiply that over. That is the first thing I would do. So I would have 1 less than or equal to all of this, because I would get rid of the fraction. That is the first thing I would do. And then what would this be as a fraction? I know we have it written as 0.001, but that would be 1/1000th. So how could you cancel that out? Yeah, multiply both sides by 1,000. And that looks a whole lot better already. Still trying to get n by itself though, so what next? We don't have a name for that one. It would just be a fourth root, but I like quad root. I think we should like make that a thing. But anyway, yeah, fourth root. And then subtract 1. So this is what you're going to put in your calculator. If you go into the math menu, we don't have a fourth root, but there's an X root. So it'll let you type in any root you want. So if you go into your math menu, what choice is that? Choice 5. You can type a fourth root of 1,000 and then -1. Did you get 4.6? Yes. Okay, here's the thing though. That means n has to be at least what? But you can't do the 4.6 term. N has to be at least 5. In order for your error to be smaller than 1/1000. Because you can't have like a term and a half. Like each term is its own separate thing. So n must be at least 5. You have to do at least 5 terms for your error to be small enough.